guys, today I'm gonna use midasNFX to create this three-dimensional model with 1000 millimeter of the length for the cylindrical, and we have also the 4 millimeters thickness for the cylindrical, and also the plate. That is the first model I'm going to create, and using the same model as well, I'm going to create 4 hole according to this configuration. So then first of all, then we will start with this midasNFX, and we're going to create the outer diameter or outer radius. So according to this model, sorry, this is model, so we have to figure out the outer radius, which is, so this is the radius of the cylindrical, 52.3. So we will create a circle without the face, and 52.3. And all right, we will double check the diameter. Yes, this is the diameter multiplied by 2, 104.6. So we have here 10.6 diameter. That is correct. So which is, this is going to be the outer diameter. Then we will go for the inner diameter, which is specified here, 42.3. So we're going to create a second. So 42.3. All right. So this is the, oh sorry, this is 48.3. So undo, make face, 48.3. So this is the inner diameter or inner ring. So we check the thickness is exactly 4 mm. Then we're gonna extrude to get this cylindrical for 1000 mm. So now we're gonna create the face, of course, because it's going to be three-dimensional. Then we use extrude. So we will extrude the face, and we're gonna extrude in the Z direction for a magnitude of 1000. Preview and OK. So we have this 1000 or 1 meter, and we have created the solid, right? So we move to this dimension, this model. We're going to create the plate for trapezium plate first. We're going to have this, I believe this is 4 mm thickness. So we have 80 mm. So we're going to have to switch our reference plane. So in this case, we have this reference plane supposed to be in the something like this. All right. So this is our working plane where our draft or any geometrical will be draft on the plane itself. So it seems that it's not enough in terms of the scale, so we will create more, perhaps something like this. Preview. So we can draft much more easy, or 60 perhaps. All right, so now we will go to this. We will create a distance between this edge to this edge, because we know that this is 80 mm. So by aligning nicely, or to the right perhaps. All right, so in this case we're gonna have 80 mm. So I'm going to draw a line first, and I will check if this line with this distance in the y is equal to 80, right? So I'm going to move the direction, in this y direction. So initially I have the distance of, and I'm gonna make up to 80. So how much I gonna move? So 167.7, and I'm gonna use translate with this magnet tip. And because we are moving to the y in the negative direction, and this is what we're gonna have. All right, so let's double check again. So this is y distance. So according to what we have is 80 mm. This is going to be 80 mm. Now we're gonna have more dimension here, perhaps. I'm not sure about this one. Okay, so it seems that I do not have any dimension in this case. So I just roughly predict that it's gonna be about half of this distance. So it's gonna be 80, perhaps. Sorry, it's going to be 500 mm. So now let's activate my grid. So to make sure that just click to have these two. All right, so it seems that it's not snapping on my grid perfectly, so I may have to adjust my grid in order to cater about perhaps 10. Then I can increase my resolution. Okay, so let's make sure that this point and this point is aligned in zero, in terms of zero distance for the y, for the z. Okay, so this is z, that's correct. I'm going to create a horizontal line. Okay, any horizontal line. So this is with the reference the same distance as this edge, which is cost is 0. We assume that in this case we have gonna have 500 mm, so which means we're gonna have 250 mm and 250 mm distance over here. So we will move into z direction 250. All right, this is minus, so we move in the negative direction, and this is 250. Then okay, so this line is going to be this direction, this distance. All right, and I'm gonna go another one. I'm gonna copy this one into the another distance 500, and copy, so that I have a duplicate line. Okay, so then over here I should be able to connect to make a trapezium from this edge. So make sure that this is correct, from this edge to this point, from this point to this edge. All right, and so I have something like this. All right, so now I'm going to trim, or going to define the intersection. So once the intersection has been defined, means that the line will be cut accordingly. So we don't need this anymore. Delete. Then we have this trapezium. Okay. So just to check if this distance to this distance in the y is 80. Yes, that's correct. 80. And from here, we can create the thickness, which is 4 mm. Okay, so which is 4 mm. So what I'm gonna do is I'm gonna make a face. So the face has been created. All right, and we have 4 mm, means that we have to extrude into the X direction. Because of the extrusion is done one by one for each direction, so it means that we have to extrude in a positive in a positive direction of X. All right, and apply, and we extrude in the negative direction of X. Right, so now we have two solid. So in order to get a single solid, so we just use Boolean operation and make it a single solid. Then we should have one single solid of the plate with a thickness of 4 mm. Okay. All right. So so these are the two individual solid. All right. So we are going to do the attachment from this solid to another solid by using two different methods. One is Boolean and one is creating the contact. But before doing the contact or the Boolean, so we will try to finish all the model. We're going to create a square plate over here. So I assume that this square plate is going to have 80 mm in each of the edge with a thickness of 4 mm. I'm going to assume that this plate to be sit into the middle of the cylindrical, whereas the other two will be sit at the edge of this trapezium. All right. So I'm going to create square, this square model or square part. Then once has been created, I'm going to do a duplicating by transferring the distance from this one to this point, and I'm going to do a duplicating as well to the other side. Okay, so before I'm doing anything on that, so I just make sure that my working plane is properly sit on the desired location. So in this case, I'm going to move my working plane into somewhere here, sorry. All right, so this is the working plane in the X and Y, and I'm going to move this working plane into the direction of 500. Let's see, yes. So which is going to create this 4 mm thickness. All right, so I'm going to align my view to perhaps bottom. Okay, so according to the schematic, I'm going to have this edge over here. So how am I going to do that? I'm going to create the rectangular. Okay, so just place it anywhere. So once I place it in anywhere, so I should be able to create 80 by 80. According to this one, yes, it's 80 by 80. All right, so later on I will move it and place it accordingly. So I will just translate. All right, so I'm going to translate into perhaps X first, from this point to this point, and I'm going to press this button, which is auto calculate the distance, and I'm going to preview. All right, so this is okay. Then I'm going to move into Y direction from this point into this point and preview. Okay, so the square has been sit properly. I'm going to do the same thing in order to create the thickness, which is the 4 mm. I'm going to extrude. All right, so in each of the direction, here is Z direction. I'm going to extrude in the positive direction first by 2, preview, right? And I'm going to extrude also in the Z direction, -2, preview. Then I'm going to have the plate here doing the booling. So we have one plate sitting in the middle of the cylindrical, according to here. Right, so I'm going to move and copy this one into this point and another point. I'm going to use a translate and let's align. Let's select the target. Okay, so I'm going to move into Z direction. I'm going to move the edge here to this edge. Make sure you click on copy and auto generate the distance and preview. So we have one here. So we're going to have another one here. Okay, done. So this is how you create the plate according to this dimension. All right, so I did mention that since that this is the plate has been overlapped, so I believe that this is going to be one model. So there are a few ways of doing that. All right, so I prefer to use boolean operation in this case. Let's save the model first. Let's say this is the NFX one, perhaps. Yes. Okay. So what you can do is you just go to boolean, okay, and select all, and press OK or apply. So you should be able to create one single geometric. All right. So this is one way of doing that. So if you would like to determine the contact, all right. So since that this is overlapping, it's not supposed to be in this way. Before I do the contact, so I need to make a cut. I make sure that this is cut from the tools, right, without deleting the tools, and apply. And this is how suppose it looks like, right? So one part here, another part here. So you're going to repeat the model again. So I'm going to cut this one over the tool surface, or the tool object, sorry, and press apply. So we're going to have two parts, and as well as it goes for this target and the tools, and OK. So 1, 2, 3, 4, 5, 6, 7, and 8. Right? Okay, so you still can perform a boolean operation in order to combine all the parts if you want. The same thing, you just select all using the boolean, then you can fuse or to merge all the part together to make sure that all of these parts of the geometry are bond together. The second thing is you can use a contact, right? So if you notice that the contact is only appear in the analysis, which is a static heat analysis or the dynamic heat analysis, all right? So any one of these contact will be the same, okay? It doesn't matter. So we can use a manual contact or we can use auto contact, all right? So before we do contact, you will notice that the information of the contact will be kept in this folder. So there is none of the contact has been created yet. So what I'm going to do is I'm going to use the auto contact to create the contact pair, and I will select everything. Oh, sorry, so this is mesh. We're going to select the geometry. All right, so all the geometry has been selected. Then we will create a different type of contact according to your requirement. All right, so the welder contact, directional contact, rough, general, and breaking weld contact. And most of the case, if you are having the welded, so or welding contact, so this is supposed to be welder contact, and press OK. you see that the contact pair has been created automatically, right? Which means that it's welded or it is bond together. So what will be the difference between the boolean and the contact, right? So in contact, you can define uh, additional parameters. For example, like how the contact works, what type of contact to be created, what is the strength in terms of the tangential strength or the normal strength between the master part to the slave part, right? This is what you can do in the contact. But if you do a boolean, means that the rigidity of the combination for all the parts are assumed to be 100% rigid, right? So without doing any, you still can do that you can define 100% rigidity in the contact as well without any problem. So by default, the default parameter has been defined. It assumes that the rigidity is 100% unless you specify what is the scaling factors, tangential factors, and etc. All right. So the contact has been there. So if we would like to do a first analysis, okay, so when you have created the contact, the properties together, so make sure that the contact pair has been selected over here. Okay, so we're gonna move on to the second part. So how we're going to create the hole. The same thing. Let's activate our grid. Let's move our grid system into the plane. All right, so in this case, you're gonna sit on the face. Let's select on this face. All right, so we're gonna draw a circle on those face. Okay, so I do not have the dimension in this case, so let's assume that we're gonna have a 4 hole with the equal dimension. So gonna have 1, 2, 3, 4, and 5. So let's say, for example, like 1000 divided by 5, we have 200 mm. So let's do a sketch first of the circle, then we'll move the circle. Let's make a circle about, let's see how much we can make the circle, perhaps something like that. Yeah, we can use this face perhaps. Alright, so let's make something like this. Is it too much? Yes, I think so. Yeah, this is too much. Okay, so we can use this one perhaps, right? Okay, we have a face. Okay, now we're gonna move and make sure that this is 200 in the Z direction, the first circle, right? So I'm gonna make sure this to this, and this is supposed to be in Z direction, 150, right? So I'm gonna move another 50, so that to make in total of 200 mm from the edge. I'm gonna move in this one 50. Okay, preview, yes, right? So that is the first one. Let's align into, nope, yeah, it's supposed to be here. Okay, let's off this one. Okay, so yep, this is okay. So I'm gonna translate this object into the Z direction with minus 200. I have 1 and I have 4. Okay, so this is just a surface before we do a extrude cut. Alright, so now we're gonna do an extrude cut. Let's say first, okay, let's go geometry, boolean. Okay, so we don't have extrude cut in this case. What I'm going to do is I'm going to extrude first. I'm going to put into 2 steps. First, I'm going to extrude. After I extrude, Then I'm going to cut it using the boolean operation. So let's extrude. So whatever distance, that is okay. So this is going to be this is going to be positive x. Let's see if 10 is good enough. Yeah, this is good enough. Okay, then I have 4 additional cylinder. So I'm going to split into the second step, which is the cut. So let's select the target. Oh, sorry. Let's select the target. Let's select the tools. So the tools is supposed to be this one. Sorry. The target is here. The tools is this. Okay, so we can select from here actually. Huh? So then if you don't need the tools anymore, then we can delete, activate the delete tools, and the tools has been deleted. Then we have this model. Let's check. Yep. Okay, thank you.